and hi to all students. I hope that all of you are doing great and fine at home. Okay, so today we continue again on our lecture of topic 11 on chi-squared test. Alright, to be exact, the scope of discussion for this topic is on chi-squared test of contingency table. Okay, so the reason, so for as introduction lah, why the reason we use this test. Okay, sorry, before we go into that, you can refer to this note as usual from UKM Folio. I already upload this particular PowerPoint in UKM Folio. Alright, so again, as an introduction, chi-squared test, especially of this contingency table, okay, is used to infer whether two nominal variables in the population are related. Again, to emphasize that our discussion here is about to infer of a certain population that we are planning to measure. All right, so here in this topic, chi-squared test of contingency table, the reason is to infer whether two nominal variables in the population are related or not. Okay, so contingency table is actually a pivot table lah. Okay, we have variable in the column and also in the row, so that's why we call it contingency table. Okay, and the count, the frequency that falls into the combination of this row and also the column. Okay, so such table we call it also as cross tab or matrix report. Okay, so we'll see later on how does it look like. Okay, so basically chi-squared test of contingency table is used to, okay, as you can see here, is used to examine whether there is enough evidence to infer that two categorical or nominal variables are related or not. Okay, so in category, so we'll see that either, for example, maybe car, type 1 or type 2, so categorical variables. Okay, so that kind of variables that we are looking at, and we want to see whether these variables are related to each other or not. Okay, so this is kind of test of independence, and in these applications, the test builds on comparing observed frequency in the observed and also the expected frequency of occurrence in all the cells. Like I said to you just now, in the contingency table, especially we can look at when we put it into an Excel file. Okay, so we can see that there will be variable in the column and also in the row, and then we see on this combination what falls into the specific cells. So this kind of relationship that we are looking at, and this is what we call as the one that we mentioned, chi-square test of a contingency table. Okay, so this is what is all about of this topic. Okay, so now we move to the next slide. So basically, the symbol or the notation of chi-squared is look like this. Chi-square, forgot the terms of this notation, but this is the notation of chi-square. And again, because this is chi-squared, right? So squared, so that's why we have this squared here. Sorry. Okay, so characteristic of this chi-square distribution, like I've also explained throughout our discussion in our lecture. Okay, for each, like for example, standardized normal table, the Z table, right, the T table, and F table. Okay, all of this distribution, the statistical table that we are referring to, they show how the data or observations distributes. Okay, and this is why different kind of table, they will different shape of the distribution. For example, previously you have seen the F table, if I'm not mistaken, right? T also, they have their own characteristics. Same goes to chi-squared. Okay, and here characteristics of chi-squared distribution. The first one, continuous and positively skewed. Okay, some sort of like similar to the F table, and also its values from 0 to infinity as well. So as you can see here, positively, right? Positively, so it's like the graph or the illustration will somehow move to the right because this is positively skewed in bahasa terpencong, so it will be like more into the going more into the right side. Okay, and values from 0 to infinity. Of course, as you can see from the shape here, it can move up to infinity here. Okay, so it can go infinity. All right, and there's a family of chi-square distribution, and each member of the family is determined by a degree of freedom. So still we need to find the DF in order for us to read the critical value from the chi-square table. All right. So basically, this is statistical table on chi-square looks like lah. Alright, so you have the degree of freedom on this side. Okay, and also here you have it depends on the alpha lah. Okay, of the level of confidence of that particular question. It depends on the question given to you. Okay, so this is basically how it looks like. Okay. So of course, when we're talking about chi-square test, the name itself reflects what's going on or what's to do next. Okay, because test, as usual, when we talk about doing testing, statistical testing, you want to measure. As you know from the beginning, the definition itself is saying that it wants to infer whether the two nominal variables or categorical variables are related or not. Am I right? So of course we straight away can imagine the steps will involve of the testing of the two variables. Of course it will involve the hypothesis testing. So of course the first steps, okay, we will be needed we will need sorry we will need to define to define the hypothesis. Okay, the hypothesis of this chi-square test. Okay, so the general hypotheses are H null, the two variables are independent, because again, okay, from the basic definition of this chi-square testing, the reason is we want to see, to measure, to infer whether the two categorical variables are related or not, right? So related means you are related depending on each other. So of course the H alternative will stated that the two variables are dependent. Okay, and obviously the H now will be the contrary one, which is the two variables are independent. Okay, now because the reason here, if you still remember, like I said to you, for the hypothesis alternative is the one that you are trying to achieve, the objective of the experiment that you want to achieve. And of course we want to see the two variables are related or not, so that's why it falls under the hypothesis alternative, and basically the hypothesis now will become the contrary version of this H1. Okay, so the next one is the test statistics. So to remind you again, the test statistic is basically the one that we calculated, the statistical value, the one that we find from the calculation. Okay, so this test statistics of the chi-square here, okay, is basically the one that we calculate. So this is the formula that we need to do, we need to calculate, and then later on in the next step will be comparing with the critical value. Alright, so not to make yourself confused here, test statistic of this notation is for chi-square. Right, so chi-square, and what is it all of this notation involve? Okay, we can see here Fij is the observed frequency in row I, column J. Of course, like I said to you, the contingency table will involve of the variables that will be in the row and also in the column. All right, so of course there will be observed frequency in the row and also column J, and expected frequency in row I and column J. And how we want to to get this expected, it is from this following formula: expected frequency in row I, column J. So you take the row total times with the column total divided by n. What is n? N is the sample size. So this is basically what is all about that we need to calculate first. All right, and Ri is the row I total, Cj is for column J total. Alright, so Eij is basically the expected frequency. So how do we get this? This is the one that we are talking about just now. The expected frequency from this formula, row times with column total, R times with CJ and divided by the sample size. So basically, this is the formula that need to be used to calculate for the test statistic of chi-squared. Okay. So moving further, the next step is on decision rule. So basically, we are looking at the steps involved first. Okay, so later on we'll see the example on how we want to apply this. So of course, the next step is the decision rule. But for this decision rule, of course, you need to compare it with the. So this is the one that we get from where? From the critical value. Critical value is from where? From the table. Okay, from the chi-squared table. So how you want to read it? Okay, wait. So this one is the one that we take from the test statistic, the calculated one. Alright, so this is from the calculated one, and the other one is from the statistic table. Okay, so from the statistic table, again, how do you take it? So chi-squared, you take the alpha, the confidence level, r minus 1 times with c minus 1. So this is the formula, yeah, the one that for the degree of freedom, df. So basically, let's say your r is 5, so you minus with 1. Let's say this is just an example, alright? So let's say your r is 5, your c is 4, for example. So basically, what will be the df is 5 minus 1 times, yeah, times with 4 minus 1. So basically, will become 4 times with 3. So you'll be getting your df12, something like this. Alright, so this is just an example. Okay, so r is the number of row and c is the number of columns in the contingency table. So it depends on the table that you're given in your question. Okay, so as a rule of thumb, each expected frequency should be at least 5. Okay, so this is because the chi-square distribution is continuous, while the counts on which the test statistic is based are discrete. So the approximation will be unsatisfactory when one or more expected frequencies is very small. So very small is like the likelihood is a bit difficult. So it's better to be minimum 5 or more is much better. Okay, so now we look at the example on how we want to solve a question pertaining chi-squared test. Alright, so looking at this table below, the information show the information about the media that primarily people get news according to the age group. So this is the one that I mentioned to you. How does it looks like for a contingency table? So basically, what we are telling is we want to see to infer the relationship of two categorical variable. Am I right? Whether it's related or not. So it's something like this. The objective of this study is to see the relationship between the age group and where do people get their news, the sources. So basically, they want to look at the relation between this age group and also the sources of the sources. Where do they get news? Either from local TV, national, or radio. So this kind of relationship they want to infer between categorical of age. This is also considered as categorical variable, am I right? And the other category is media. So media, it can be either of these three sources lah. Okay, so basically this fits right with the terminology of chi-squared. Okay, so they want to infer the relationship of two variables here, which is categorical age and also category of the media or the sources of the news that they get. Alright, so basically this is what the one that I mentioned to you, the contingency table, which have variable in the column and also in the row, and we want to see the frequency that falls into the combination. For example, combination of age below 36 and the sources from local media. So you get the frequency 107, something like that. So this is what it means of the definition of the chi-square test of contingency table. So now they give to you also the information of the level of significance, okay, alpha here. So is there evidence of a significant relationship between the age group? So see here, the category is age group and also the sources of the, where do they get the news lah, okay. Okay, so the first one is to define the hypothesis. H now, there is no relationship between the age group and also where people primarily get their news. So the H alternative, of course, the contrary, there is a relationship between the age group and also where do people get their news. So you want to test this hypothesis. Okay, so again, here is the table that are given to us just now, which is the age and also the sources of media. All right, so now you can see here in the parentheses or in the bracket, they have said they have some other value here, 85.8. Okay, here 105.6. So what is this value? All right, so basically for this table, expected values given in this parenthesis or the bracket one. So again, expected values is 1, the row times with columns divided by your n. Okay, so row times with column. What does it mean here, row times with column? Okay, so we look at this example here. Now they zoom in, how do they get the expected value from the one in the bracket, right? How do they get the 85.8? So basically it looks like this. So they take the row of this, for example 89.7. How do they get this? Okay, if you see from the beginning of the first slide that shows the information here, right, they have the total for each of the row and also each of the column. Am I right? So for the age, like for example less than 36, and sorry, less than 36 to 160, local TV 330, something like that. So now, okay, meaning, sorry, also here they give here also. All right, so row total, what is the row total for this national TV? National TV, if you can see, row is 345. Okay, and then this national TV is falls under this column, right? Less than 36. Less than 36, the total is 260. So you take 345 times with 260 here, divided by what is n, and of course the total of the sample size, which is 1000. So they get 89.7. Same goes to others. For example, maybe you are talking about this one. Okay, so again, how do they get 85.8 here? Okay, so for example, we want to calculate this one. So basically, it will become 85.8, meaning that you take this EIJ. So you take, let's say you want to calculate 85.8 here. How do they get this? They take 330. Okay, because the value of the row here is 330, the total. Okay, now it is under less than 36. Less than 36 column, less than 36 column, so times with 260 divided by again the same 1000. So basically I haven't calculated this one, so you should be getting 360 times with 260 divided by 1000. So basically you should be getting yeah, wait, 330 times with 260 divided by 1000. So you'll be getting the same amount lah, which is this one, 85.8. Okay, so the same thing also. So same goes to apply to this one. It depends lah. If let's say you're talking about this one, age group 36 to 50, meaning that, okay, or other way that to explain it to you, if you can see here, expected is EIJ, right? What is EIJ? I is for the row, J is for the column. So for example, you are talking about, so this is of course row 1, row 2, row 3. And this is column 1, column 2, column 3. So basically, if you are counting for this one, local TV, and for age group less than 36, for here, for example, so basically you are talking about row 1, column 1, E11. So here, for example, they are calculating for this national TV here. So this is basically they are talking about row 2, column 1. So E21 here. Okay, so you can also name it this way so that you don't get confused. So you can also refer back lah. Let's say you are talking about row 1, column 1. So row 1, so you take the total of row 1. Row 1, total of row 1. And then column 1, so you take the total of column 1, which is 260. Just not to make yourself confused. Alright, so basically you need to count for each of the row item in the cells. Okay, and also for the each of the column as well. And then you should be getting the value of this one lah. So basically this table is only on the expected value only. Okay, so on this table that they show in the previous slide here is the frequency and also the expected value as well in the bracket. Okay, So done with that of calculating expected values. Alright, we move to the next slide. Now you can see here that they put into this table, this is the frequency for each of the row and also column, and this is the expected value of the row and column. Okay, so here, alright, so they put it separately. Fij, the Fij is the frequency basically for each of the row and also the column in the table from the question just now, right? So they put it into this table to have a better view. Why we doing this? Because as you can see, right, from the test statistic formula just now, the test statistic for chi-square something like this. Okay, basically, so maybe I move to the slide of this. Okay, if you can remember, the formula is this one, right? Chi-square equals to, you take the summation of all the row. Of course, you are taking into consideration everything, right? Every row and also every column in the table, right? So, and then you take the frequency for each of the row and the column minus with the expected value for each of the row and column, the one that we calculated just now. That's why you put it under the frequency. For example, yeah, why I'm saying this, the one that in this table, if you can, sorry, not this table, here, this is the Fij and this is Eij. To be exact, what does this mean? This is F. What is Ij? I is the row. So this is row 1. Column 1. Same goes to here. Here is Eij also. I for the row 1, column 1. F11 because we are talking about the frequency, and this is the expected value E11. So basically what we need is we need to Fij or F11 here minus with the respective expected value, which is E11 also Eij. So here Ij. Okay, so Eij here. Okay, so so if you're taking row 1 column 1, so of course here will become F11, here also will become E11 and we squared. So like just now, it is 107, right? Minus with 85.8. So you need to square and divide it by Eij. What is Eij? Expected value. Okay, so now we go into that slide to see how does the calculation looks like. So that's why they put it separately in this table to have a better view lah, so that we don't take the wrong value. For example, you can take F11 but you go and take E or the expected value from other column. That's not right. That's why Fij here, this is talking about this 107 is referring to or infer to which cell? For the cell of row 1, column 1. So here also row 1, column 1. So you are talking about the same thing, I mean the same cell. So then you can proceed to the next step, which is the formula of the test statistic of chi-square, which is you take the F11 minus E11 squared. So you take 107. So basically this one will be 107 minus 85.8 squared. Okay, and what is the next step? You need to divide it by 85.8, yeah? Maybe I just write it I write it somewhere here. So sorry about this. What's wrong with this one? Okay, so basically you take the value of F11 minus E11 squared. So the thing for, so now I show the example for the first one lah. Okay, for the first one here, how do they get this? So you're calculating for calculating for the test statistic for the row 1, column 1, right? So we are referring to here. So basically the value that you put in is 107 minus 85.8. Okay, so this is basically your F11, Fij, right? This is your Eij, which is E11 85.8. So you need to square this one. Okay, done. Squared. Okay, and then you divided by Eij only, Eij, which is 85.811 for this question. So basically you should be getting 5 point, you should use different color here. Okay, so you should be getting 5.238, same like this one. Same goes to here. This is 119, so basically you should take 119 minus 105.8, 119. So minus with 105.6 squared divided by 105.6. So you should be getting 1.700. So the same procedure throughout the table. Okay, so you you accumulate all the value here for all the value of the test statistic you calculated here, because basically what do you need to get at the end is the summation, yeah, the summation for all, each row, each column. So what do I mean is that's why at the end, the objective of you doing this is to get this value of all of this summation. Okay, because you look back at the formula here, the formula needs you to calculate for the summation of all row, all column, right? That's why you need to total up all the calculation of the Fij just now. Not Fij lah. This column, this Fij minus Eij squared divided by Eij. So you need to accumulate total up. So this is basically the amount that you need actually at the end. Not all of this. You need to accumulate. So, and then you need to compare this with what? With the value you got from the critical value. What is critical value? You read from the chi-square table. So now, for this question, again, how do we read this? Okay, if you forgot already, chi-square for critical value, we take the alpha. Then for the degree of freedom, you take R minus 1 and you times, you times with C minus 1. So basically, I will write it up here, degree of freedom for chi-square. So basically, you need to take R minus 1 times with C minus 1. So in this case, what is your row? Okay, so now we look here. Your row, you have 3 rows, 3 columns. So basically, you have 3 rows, 3 columns. So 3 minus 1, 3 minus 1, right? So you should be getting 2 and 2. So what you get? 4. So that's your degree of freedom here. I hope it clears here. So alpha 0.05, and how do I get 4 is here from the calculation of degree of freedom here. So where do I get this formula? It's given here in this line. Okay, we scroll back here in the decision rule here. Okay, so you get the components, and then you get chi-square 0.05 for alpha, and then you get here 4, right? So you move to the table. So basically, because it is 0.05, that is your degree of freedom here, right? And this is the column, and what is the row? Degree of freedom is for the row, right? For the row, and what is the row? 4. So you go and take the value here, which is 9.49. 9.49 here is for the chi-square critical value. Okay, critical value here. So that's why, and then you get the critical value. You compare it with the one that you get from the test statistic, which is from the calculated one, right? Which is 24. Calculated one is the one that you get from here, 24.320. 320. So you compare it with the critical value, 9.49. Of course, obviously, it is higher than. So you need to reject, because if you look back at the illustration of the distribution shape, for the chi-square, how does it look like? It looks like this, right? So basically, your chi-square here is the one that you take from the CV or the critical value. What is it? 9.49 in this case lah, in the question that we discussed just now. And then your calculated one is 20. How much is it just now? 24. Forgot already. Okay, 24.320, right? So this is the statistical value. 24.320 is the one that you get from your calculated, right? So of course, it is in the what area here? Rejection area. Rejection area or region, right? So that's why at the end, the decision is to reject the hypothesis now. So meaning that when you reject the hypothesis now, what is the one that you can conclude? There is evidence of a significant relationship between the age group and where people primarily get their news, because when you reject H now, meaning that you accept your H1. Okay, so that's all for this topic of chi-square that we can discuss here up to now. Alright, so I hope that this explanation helps you in a way to understand on doing this or performing this chi-square test of contingency table. Okay, thank you so much.